Hello again, everyone. Okay. Hope this is recorded. Okay. Okay. Let me check it again. Okay. Check everything on set. Ah. Yeah. Great. Okay. Due to the previous video, I already teach you the lesson on liquid, which I still feel a little bit excited, and will try to do my best for you all. Okay. Okay. Ah. So there are 10 exercise right here, and uh I will show how to get the answers, especially some selected ones. The rest that I didn't do will not be the part of the final exam. Okay, so you can focus just only the ones that I give you the answer and how to find the answers in this video. So the rest is the rest will not be in the part of final exam. Okay. For the first one, it's about the units transition. Okay. Uh, for this one, a guy has a blood pressure 100 for systolic and 70 for diastolic millimeter of mercury. So we transform the unit into ATM Newton per square meter and millimeter water. Okay. Uh, just do uh one by one. I consider the systolic pressure first. P of the systolic is 100 millimeter of mercury, right? If you would like to turn into ATM, okay, ATM, shoop, shoop, the one that you would like to have is the ATM, right? So put it on the top, okay? And the one that you would like to get rid of is millimeter of mercury. So see here, which one that you would like to apply? I would say the same because it is a millimeter of mercury and ATM. So I put here. Mhm, and here. So you can see that the unit cut each other right now. You can get this one. You can answer this one or this one. Up to you. Up to you. It's okay. Both got the full score. And another one is the Newton per meter square. Here. Shoop, shoop, shoop. You would like to get this one, this unit right here. You put it right here. And then you want to get rid of this one. So here is a little bit problem because there is no direct relation that I give you right here. No, this one, no, this one, no, this one. and how you make it. Uh, Actually, in the final exam, I will give you all the equation and all the transformation that is necessary. You don't have to remember anything, okay? You just have to understand that uh, how how to get that from the hints that I already put it in. Okay. And for this case, if I don't know exactly how to change from millimeter of mercury into Newton per meter square, I would do something like this. I know that I can change from millimeter mercury into ATM, right? And I know how to change from ATM into Pascal, Pascal or Newton per meter square, which is the same thing. Okay, you just put it, choop, choop. And I know that one ATM is just 1.01 times 10 to 5, something like this. I will always give you this one, but for this case, you can recall in the lecture, which is 1.34 times 10 to 4 Newton per meter square or Pascal. So you don't have to worry about the relation between numbers. I always provide. Don't worry. Okay. So for the uh, millimeter water, very easy one. You just right here, 100 millimeter Hg. You try to get rid of it. You put it here, right? Shoop, shoop, right? Millimeter water, and use this relation. 1 and 13. Yeah. You finally get 1.35 meters. You can convert. You can convert. You can convert. It's up to you. Up to you. You just try. For the next one. Oh, sorry. I will not do the pressure for diastolic because it just changed the number 100 to 70. You just try it. Just try it. Okay. Just change this number, this number, this number, this number. That's it. Okay. But it follow the same method. Mm. Okay. For this one, the glass of water with 12 centimeters of height. Okay. When you do something like this, you have to understand each sentence. You have to understand sentence by sentence. Ship, glass, okay. 12 centimeter height. Okay. Find the gauge pressure. Oh, gauge pressure. PG is rho G H. Okay. This assume that uh it contain all water. Mhm. Not just the gauge pressure, but also the absolute pressure or total pressure of water at the bottom of the jar, right here, right here. So use this one, the acceleration, use this one, the density of water. Okay, to get this, the P total is the P of the atmosphere plus P gauge. Then we would like to start from the gauge pressure, rho G H. When you try to do this, I recommend you to write number and then write the unit. Mhm. It would be protective. It's like a prevent you from using the wrong unit. Okay, because when you write this, you write number and then you write the unit. You would see that right here is the centimeter, but actually in SI unit we use meter. Then you would know that you should change it into meter right now itself. Okay, and you can do it by yourself without calculator. You can get 1.2 times 10 to 3 kilogram per meter square. As you can see that I can get rid of meters mhm, into this. Okay, and how do we make it sure that it is the unit that we want? Because this is not the Pascal that I already mentioned, right? So this unit, if you want Pascal, which means that you need Newton per meter square, right? And Newton per meter square is kilogram m per sec square by m square. So should it would become kilogram by meter sec square. Oh, which is the same as this one. So we would conclude that this unit is Newton per meter square. If you cannot move, you cannot do forward from kilogram per meter square, sorry, kilogram per meter second square into Newton per meter square. You can do inversely. You can start from Newton per meter square and then try to expand from Newton into the unit of mass and acceleration, right? And then after you multiply it, you will get the result as this. Okay, here, right now. This is pressure from the gate pressure, but you have to do another one, which is the absolute pressure, right? P absolute pressure or total pressure is the pressure of the atmosphere plus the pressure from the grid pressure. The atmosphere is around here. Don't worry, I will give you the value of this one, so you don't have to remember it. Mhm. So can you make it happen? This is the same unit. Mhm. If you can't, you see the lowest, which is 10 to 3. So you try to make it into 10 to 3 unit. The first one will be this one, plus 0.2 P. And then it would be P. You answer this, it's okay, it's all right. But we don't usually use this one. Oh, sorry. Okay. We don't usually use this one. Oh, sorry. Okay. We don't usually use this one. We use the scientific star here. Mhm. You can either enter and you can either answer into Newton per meter square or Pascal, which is the same. Just choose. It's okay. You can answer like this. I wouldn't cut your score. Okay. For the next one, uh, for this case, estimate the force exerted on your end. Mhm. Due to the water above when you are swimming at the bottom of the pool. Okay, here, here you are, right here. No, you are swimming. Okay, not just lying down. Swimming. Okay, swimming. 5 meters below. Mhm. And okay, here is the G. Don't use 9.8, just 10. Okay. Density of water is 1,000. And the surface of the area of your air drum, which means around here, your air drum, the area is 1 centimeter square. Okay. Find the force. May the force be with you. Mm. F equal to pressure times area. Okay. Because it is from the definition of pressure, which is the ratio between the force and the area. Like this. Yeah. All you have to do is to calculate the pressure. Okay. Just the pressure. So here, it would be this choice or this one. Which one? Which one? So right here, it depends on the problem. So if you read it right here, estimate the force exerted on your eardrum due to what? Due to the water above when you are swimming. So this problem didn't mention about the atmospheric pressure. Then find only the force exerted from the water above only, which means that they want us to find the force from the gauge pressure. Okay? Then for this case, ignore the atmospheric pressure is outside this problem. So become rho GH and the area. Right now, it's time for calculation. Shoop, shoop. H is 5 meter and area is 1 centimeter square. Mhm. You would get 5 times 10 to 4 kilogram per second square and centimeter square per meter. You can change the unit. Chip right here. 1 centimeter is 10 to minus 2 meters. Mhm. You combine the numbers and then you will get here. Choop. Mm. Here, cancel each other, and you get just only 5 kilogram per meter square or 5 Newton. That is the answer. Okay. The technique that I use right here is that I know that 100 centimeter is 1 meter, right? So 1 centimeter is 1/100 meters, or right here. So the problem is 1 centimeter square. It would be 10 to minus 2 meters square. Mhm. That's it. Choop. Okay. For the Pascal principle, it's about the hydraulic. Uh, it's about hydraulic. And you will be clear in the application right here. So from the diagram in figure 1, the narrow piston in right here, right, has the area about 2.5 centimeter square. However, right here, the Y piston area is 100 centimeter square. Mhm. There is a weight right here, 2.5, 10 to 3, 2.5 kilonewton. Mhm. And the question is to find the magnitude of the force F here to lift the block W. Mhm. How much for the force to lift? So I assume in this case that the gauge pressure change is zero, which means that it's almost the same level. Uh-huh. I would say that pressure at point 1 and the pressure at point 2 is equal. Oh, are equal, sorry. P1 equal P2. And P1 is the ratio of the force and A1. While the P2 is the ratio of the weight by A2. To find F, F is A1 by A2 and weight. Mhm. The weight is about 2,500 Newton. And A1 is just only 2.5 centimeters square. A2 is 100 centimeters square. You do not have to change the unit from the centimeter into made because it cancels out. Mhm. And the final answer is just only 62.5 Newton to lift 2,500 Newton. That's it. This is the least force, the least force that can lift uh, 2,500 newtons weight. Mhm. That's it. See? Easy, not that hard. Okay? Okay. And for this one, a student measure the pressure of gas in a tube, which means remain unknown. Remain unknown. Okay. Would like to know the pressure right here. Uh, Using the below equipment. Okay. If the atmospheric pressure, P atmosphere, P ATM is 76 centimeter of mercury. And right here is the height is 5.5 centimeter. So find the pressure of the gas in the tube in the unit of meter of mercury and Pascal. Okay, all you have to do, all you have to do is to find the connection between the source of the pressure that you would like to know and the pressure from the atmosphere. I would say I would say here P1 and P2. Okay. And we know that P1 equal P2 because it is the same level of the mercury, connected mercury. Okay. Just consider P2 first. P2 is directly from the atmosphere. Mhm. However, from P1, P1 has two factors. P from gas, right? And P from the gauge pressure. P from the gas is still unknown. P from the gauge pressure can be calculated by rho gh. So P gas equal to P atmosphere minus P gauge, which is 76 centimeter of mercury minus 5.5 centimeter. Actually, it's a 5.5 centimeter of mercury too. Mhm. But it is in the unit of centimeter. It's okay. You can get the final answer, which is 70.5 centimeter Hg. That's it. This is the unit of the it is the unit of the pressure of the gas. This gas is this gas has lower pressure than the atmosphere. Mhm. Normally, but right now it's 7.5 centimeter of mercury. You can change the unit into Pascal. It's very easy. You can do it by yourself. For example, here is your you would like to get rid of this into Pascal. So use the ones that I already give you. Here, 1 millimeter Hg is uh you can use here. Okay, I was right here. Shoop, 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 shoop. Mm-hmm. You can you can see that. Oh, it's all right. But it is center Hg. It is millimeter Hg. So before that, you can use this one. You can change from centimeter into millimeter. Shoop, shoop. And then the rest. This one can cut this one. This one cut this one. The rest is about the calculator. So you can use calculator and answer in the unit of Pascal or Newton per meter square. That's it. So right here is almost the same thing as this one. But when the gas is connected, the height in the mercury in the side of the gas is below than the other. So you just flip, you just flip like here. P gas equal to P gauge plus P ATM. So in this case, you will get the pressure of the gas higher than the pressure of the atmosphere. I will not continue this one. It's quite the same. Okay, it's quite the same. Okay, for the next one is the buoyancy force. Um, for this one, Archimedes supposedly was asked to determine whether a crown made for the king consists of pure gold. Mhm. So the king is not sure. Legend has it that he solved this problem by weighing the crown first in the air and then in the water. So as you can see on the right and the left side of the pictures, suppose the scale read 7.84 Newton in the air. Okay, which means that T1 is 7.84 Newton. But because it stays still, so the summation of the force is cancel or zero. So Fg minus T1 is zero, or Fg equal to T1 equal to 7.84 Newton. Okay? And when he put it into water, right, the gauge is 6.86 Newton in water. Oh, which means that 2 is 6.86 Newton. Hmm. Okay. And if you read this one, it stays it stays still. So summation of the force equal to zero because there is no acceleration to the system. Uh, the direction of this I would change from B. B is a plus. Fg is the minus for this case. Uh, for this one, I put everything that point upward is plus. But right here, anything that point downward is plus. Okay, just show the difference. But actually, it is the same thing. Uh, B, which is the buoyancy, is the difference between Fg and T2. Fg is 7.84 from the calculation before, and then T2 is 6.86 Newton, which means that the buoyancy force is 0.89 Newton. Okay, then what happened next? How do we calculate next? The question is, what should Akim have told the king? Okay, is the crown is a pure gold or not? Mhm. The key is this one, the buoyancy force. Actually, the buoyancy force is the force that is replaced by the crown. The buoyant force would be the rho T V. Right here, it would be the density of the water because the water is replaced by the gold. And this is T, and this is V. Okay. Buoyancy force is here. The density of the water that is replaced by gold is 10 to 3 kilogram per cubic meter. Sure. Mhm. And you can calculate that. Finally, the volume of the water that is replaced by the gold is 10 to minus 4 cubic meters. which is the volume of the crown as well. Okay, so the next step is to calculate the density of the crown. Rho of the sea equal to the mass of the sea. I mean the crown by the volume of the crown. I just asked this one. G, shoop, G, which can be interpreted as the weight of the crown, right? Which is 7.84 Newton. And weight of the crown is 10 to minus 4. Shoop, and G is 9.8. So you can get it around 8,000 kilogram per cubic meter. However, the density of gold is more than that. It is 19.3 10 to 3 kilogram per cubic meter, which means uh, the crown maker didn't have did, didn't use the full gold, just use less than half gold and add something to the crown. That is the reason why the density of the crown is lower than the actual pure gold. So this is what the this is what Archimedes told the king that he was fooled by the crown maker. Mhm. So the tip of iceberg I would skip, so there will be no more in final exam. Okay, I skip this. Um, and I will skip this one as well. Okay, no, this one in the final exam. And the last one that might be in the final exam is about the Bernoulli equation. This is very simple, and I try to simplify so for everyone to calculate it. Okay, an airplane has a mass around 1.6 times 10 to 4 kilogram is about 16 tons. Uh-huh. 16 tons. Each wing has an area of 40 uh, meters square. During level flight, the pressure on the lower wing surface is uh, 7 times 10 to 4 Pascal. Determine the pressure on the upper wing surface. Okay. Just consider the wing of the plane, okay? The wing of the plane. The plane can fly due to the difference between the pressure of the upper and lower, okay? Here, P upper and P lower. If there is a force lifting here, force lifting the airplane, um, the force lifting must be the pressure difference, the pressure difference times area, right? Okay. It would be the pressure of the lower minus the pressure of upper. The pressure of the upper must be less than the lower because there must be the lifting. Okay, the pressure of the under must try to compete the upper. However, the plane has mass mg. Then, if the plane is moving smoothly, there is no acceleration in the uh, vertical axis, which means that summation of the force in the vertical must be 0. Mhm. If lifting must against the weight equals 0. Uh-huh. Right here is the P lifting minus P upper and area minus mg equal to 0. But before that, no plane has only one wing, right? It has two wings. If so, the area right here, the area right here must be 2 times 40 meters squared. Okay? Because this is a plane. There will be two wings. Okay? Not don't use just only one wing to fly. Okay? It's not symmetry. Okay? Uh, the P, oh sorry, P not lifting, lower, lower, lower. Ah, so here is P lower minus P upper. Here, mg equal to 0. To find the upper, you just use the algebra. You can get P lower minus mg by 240 square meters. Ah, and here, from the problems, the lower wing surface, the pressure on the lower wing surface is right here, Newton per meter square minus the weight. The weight is 1.60 times 10 to 4 kilograms. And G for this case is 10 by 80 meters square. The rest is about the calculator. And then you will get that the pressure of the upper is 6.8 10 to 4 Pascal or Newton per meter square, right? If, if you compare to the lower, it a little bit changed, right? Just only uh 2000 Pascal. That's it. And you can lift the weight of 16 ton. Okay, hope you understand this one. And if you have any questions, you can ask me in the class or ask me via Facebook, or you can come to my office. Okay, right now, thank you everyone for this part of active learning. So remember, this part of uh, lesson doesn't, uh, it's not a, okay. this part of the lesson uh, does not involve your score, but it can hint about your problem that will be faced in the final exam. Okay, so don't forget, sorry, don't forget that you have to do the quiz in the WE learning. Okay, that is it, your score that you can get. And I hope that everyone get it full score because you can repeat it until you get the full score in every lesson that I teach you. Okay. Uh, Today, thank you everyone. Thank you again. And if there is some comment, feel free to tell me. I will approve. I will improve. Sorry, I will improve. So bye bye.